Okay guys, sorry, I don't know quite what happened on this one, but I didn't get the second part of this video, so we're going to finish this one up. So what we had talked about earlier here was surface area of pyramids, and did this one formula right here where surface area of a pyramid was the area of the base plus 1/2 times the perimeter of its base times its slant height. And that's what this formula right here in green is. That was the one we just got done talking about. But now as we move on to part 2 of these notes, we're talking about surface area of a cone. And I didn't do a good job of drawing one right here in terms of what it normally looks like. So the way we usually draw a cone, if we think about like a traffic cone or something like that, it's usually pointing upward, or a wizard hat or something like that. If we think about a cup, you know, like the kind that you might get on a soccer field with a little cooler or something like that, or a snow cone, it's usually pointing downwards. And people don't usually see it right here, but the formula for surface area of a cone is really exactly the same conceptually as the formula for surface area of a pyramid. A pyramid has one base that we had to find the area of. Well, the exact same thing happens with a cone. It has one base as well, but that base, we always know what shape it is in a cone. It's always a circle, and therefore the area of that circular base can always be found by taking pi times the radius squared. So we can actually be more specific with the formula for surface area of a cone than we could for a prism, because that generic base, well, we know it's always a circle. And then this one's a little bit harder to see, but this 1/2 times p times cursive L, the slant height right here, gave us the area of the lateral faces of a pyramid. Like for example, in this one, we had 4 particular triangles right here that were going up from the square base to this peak up here on the top. Well, that formula here still applies when we're talking about a cone, but that's not one that people see quite as much. But essentially then, what's going to happen right here is that the capital P, the perimeter of the base in a cone, well, that's always going to be a circle. So instead of a P for perimeter, we can use the formula for circumference, which is 2 times pi times r, and then multiply that by the slant height. And the only cool thing that happens here is that the 1/2 and the 2 cancel out, and we just end up then with this little formula of pi RL, and that gives us the slant height, that gives us the lateral area of the cone itself. So the pi r squared, the first term, gives you the area of the bottom down here, and the pi RL gives you the lateral area, which is going around the side. And what this little diagram was meant to convey here, it's not centered perfectly, but it's basically the drawing of a net of a cone. If you were to cut that shape out of a piece of paper and then fold everything up, this circle right here becomes your base, and then everything else wraps around it. So let's just see one example here, guys. This isn't too bad of a problem to deal with, so let's see what's going on. We have ourselves a cone. Down here on the bottom, I've given you 54 centimeters across, so that is going to be the diameter of your cone. And that 36 centimeter red segment there goes from the peak of the cone, right up here on top, down to the center of the base. So the important thing that we're going to have to get used to right now, and later on in this chapter right here, is trying to figure out whether that height right there that was given, the 36 centimeters, is the height or the slant height, or what in a pyramid we said is sometimes called the lateral edge. Well, since that segment goes to the center of the base down here on the bottom, that is the height itself of the pyramid. So we were given height, we were given diameter. Let's see what we need here. So step 1, we're going to do surface area of this cone right here to be pi times your radius squared, plus pi times r times L. Pi r squared is the area of the circular base, and pi RL is going to get you the lateral area. So let's fill in what we need here. Oop, not that. Alrighty, so here we go. Surface area is equal to, alright, so we've got a pi. Now the radius wasn't exactly given to us, everybody, but we do know that our diameter is 54 centimeters, and that means, everybody, that when we cut that in half, our radius is going to end up being 27. So the surface area is going to be pi, sorry, my dog's very excited. She's really into surface area of cones. So pi times 27 for our radius, close it and square it, plus pi times a radius, which is still 27, and then our slant height. is going to be this piece right over here on this right-hand side, which is unknown right now. So that's going to be our L. And to figure that out, we're going to do a trick that we do kind of a lot here, guys. We're going to draw a radius right over here that goes to the end of that slant height. And that height in red is perpendicular to that radius. All right, let me switch colors on you now. Let's go green here. What do we know? Well, that radius we just drew there, we said has a length of 27, and then this height going right here is 36. As you may notice, and I'm hoping you do, those two numbers have a common factor that we can divide out. That's going to be a 9. So I always like to draw that in the middle of my right triangle and circle that. And now let's see what's left. 27 divided by 9 is 3. 36 divided by 9 is 4. That means that we are dealing with a 3, 4, 5 Pythagorean triple. And if we multiply out now, the 9 gets multiplied by the 5 there on the hypotenuse, and that tells us that our slant height here is 45 centimeters. So again, Pythagorean triples save us a lot of work right there. Okay, so the L that we were missing here for the slant height, we now found to be 45. Okay, and with all that in mind, I think it's calculator time, guys, because these are going to be some pretty big numbers that I don't think I can do in my head right here. All right, so the 27 squared, well, that should get us a 729. I think that one's right. Okay, so surface area then is going to equal, there's really no need to do this as two separate steps in your calculator, but most of you guys do, so I'll do it the same way here. So a 729 pi plus, and now we need to multiply the 27 times the 45 there to get a 1,215, and the pi just goes along for the ride. And then all I'm going to do in my calculator now is add up my last answer. That's the 1215 plus the 729, and that's going to get us 1,944. The pi just goes along as a factor here, and every unit was measured in centimeters. So since we're talking about surface area, our units here are going to be square centimeters, and that is our answer for example A. Okay, everybody, that's a wrap on the notes for 11.3. Let's give that homework a try and see how you do. Make sure to put some comments on Classroom if you guys have any questions for me.